Maria Akhtar Mithila, can you just stop sharing the whiteboard? So suppose class A, this is a class, right? And now this class A can have its own data and it can have some functions. Oh, Ume Habiba, please stop screen sharing. So this is class A, right? Now, if I want, I can derive a new class from B. What is the syntax? So syntax is just use the keyword class and then the child class name, colon, and then access specifier. After that, the parent class name. So we'll use this syntax for deriving a child class from a parent class. So you must have to mention your child class name, your parent class name, and how you are actually deriving that child class from the parent class. Okay, so class B will be publicly derived from class A. Now, all the data of class A will be accessible by the class object of class B because class B is the parent child class of class A. Is that clear? That how we can create a child class? And we have an entire chapter on inheritance, that is chapter 8. Okay, on the in that chapter, we'll discuss about these things in more details, that how we can declare a child class and how that child class can actually access the property of that parent class. This whiteboard is actually very disturbing. The previous one was very much easier to maintain. Okay, let me show the slide again. So this is all about inheritance. Okay, always remember inheritance means just accessing the property of the parent class by the child class. And inheritance will actually provide the idea of reusability. Reusability means what? Suppose the same functionalities parent and child classes are going to perform, and that function is already defined in the parent class. So do we need to again define the same thing in another class? No, in object oriented programming, it's not needed because the child class can easily actually access the properties of the parent class. So in that way, you can actually implement that concept reusability. So reusability means we can add additional features to an existing class without modifying it, and it allows the programmer to reuse a class that is almost but not exactly what he wants, and to tailor the class in such a way that it does not introduce any undesirable side effects into the rest of the classes. So when you actually implement it in program, these things will be more clear to you. After that, the next features of OP, that is polymorphism. Now, poly means many, right? And morph means form. So when you'll find that some attributes, it can be function, it can be operator, which has the same name, but they're working for different purposes. So I can say, suppose I have three functions in my program, their name are same, but they're going to be used in the program for serving different purpose. Like what? Suppose I want to calculate the area of rectangle, circle, and triangle. So if I want to calculate the area of rectangle, I have to use a specific equation. And for circle, the equation will be different. And for triangle, I have to use another equation. Let me just write it down here. Uh, let's use Microsoft Word. So how we define a function? It will be like data type and then function name. Suppose the name of the function is area. And for calculating the area of circle, how many parameters I have to take?
Parameter.
How many?
To base and height. Oh, sorry, area of circle. Sorry.
Circle, yeah. There will be only one
Only one.
parameter,
Sorry.
that is a radius, right? So we can write
Radius.
integer r. And what this function is, okay, you know that this D will be lowercase letter. In Microsoft Word, automatically it's becoming actually uppercase, okay? It will be lowercase letter. And then it can return like this. You can easily understand that these are all will be lowercase letter. So return 3.14 into R, right? And now in the same program, if I want to define another function with the same name, like double, or let's say integer, and then area, and we'll calculate the area of a rectangle. So we need two parameters. One is length and another is width. So what it's going to return, it will return L into W, right? So now when you're going to call that function area, which one will respond? The first function or the second function? How are we going to decide it? During the function call, definitely the compiler will check how many parameter it has. So that's why in function overloading, which is the part of polymorphism, because you're saying polymorphism means multiple things are going to have the same name, but their purpose will be different. Like here, the function name is area, but it's going to calculate the area of circle. The second function, the area function, its name is same, but it's going to return the area of rectangle. So in the first function, there is only one parameter, which is integer type. And in the second function, there are two parameters. So that's why in function overloading, which is compile time polymorphism, the number of attributes or maybe the data type of the attributes cannot be same. Otherwise, the compiler will get confused at which function to call. So this concept is function overloading, which is a kind of polymorphism. Is it clear to you? Is this concept clear to you? The concept of polymorphism.
Yes, ma'am.
Another type of polymorphism we can have that is called operator overloading. Operator means the operations you'll perform like addition, subtraction. Suppose this plus is an operator, right? So by using this plus, we can add integer type data, or if we want, we can add float type data, as well as if you want, you can add string type data, right? So look how many types of functionalities it's serving there. In the first case, the addition, it will add to integer type data and then to float type data. After that, string type data. And when we are taking two string type data as our input and we are adding them together, at that time, this plus operator will be called string concatenation operation. That means the same operation, but they're adding different types of data. So the same thing are doing multiple work. That means they're operating on multiple type of data, and that concept is called polymorphism. And this polymorphism is called operator overloading. In chapter 9 and 7, we'll actually discuss about different types of polymorphism. There are two types of polymorphism mainly. One is called compile time polymorphism and another is called runtime polymorphism. And these function overloading and operator overloading, these are actually examples of function compile time polymorphism. Okay. So this is all about features of OOP. So now how many features we got? 6, right? That is class, object, encapsulation, abstraction, inheritance, and polymorphism. So what is encapsulation? Just keeping the data and functions together inside a class, that is called encapsulation. And abstraction means hiding the important details from the user, from the outside world, and just to show them the necessary thing they need to know. Okay, that is called abstraction. And inheritance means deriving a child class from a base class from an existing class, and the child class can access the properties of the base class. And polymorphism means multiple functions or multiple operators. They can have the same name, but they will serve different purposes. Is it clear to you all? If you have any questions, you can ask. Do you have any question from the features of OP? If not, then let's move on to the next topic, that is benefits of OP. We already know that we can ensure data security and we can reuse the code segments and we can eliminate redundant code. That means the same thing doesn't need to be written multiple times. And you can simplify complex systems and it's easier to maintain and upgrade. So these are some benefits of OP. And the applications of OP that we actually use OP anywhere, you can use them. So these are some applications, these are some areas where you can actually use OP, like in neural networks and parallel programming, real-time systems, object-oriented databases, and all. Okay, and this is the end of chapter 1. So any question from chapter 1? We can just check again that how many topics we covered. POP and then object-oriented programming. After that, some features of OP and then advantages of OP. The last topic was applications of OP. Is that clear?
Yes, miss.
Any queries you have? No. Yeah, that's great. Then let's start chapter 2, which is a very short chapter. It's a very simple one because in chapter 2, you'll just get the explanation of different statement you use in C++ programming. And you already have seen how we can write program in C++. So let's just start chapter 2. So this is the lecture slide for chapter 2. That is beginning with C++. So we already know C++ is object-oriented programming language, and we sometimes call it extension of C because in C++ you get all the features like C, like structured programming, with some additional features like the key features of object-oriented programming language. Otherwise, the keywords you use in C, the same keywords can be used in C++, and then the control structures you use in C, the same control structures can be used in C++. So that's why you can call it the extension of C with class construct, because in structured programming, actually, we don't use any features called class. That's why C program cannot actually ensure the data security. But in C++, since we can use class and object, we can actually hide our data from the outside world. So we can use some features like inheritance, polymorphism, and encapsulation. We already discussed about these features, and it combines the power of C with OP capabilities. Now let's have a look. These are the applications we already discussed, and this is a simple C++ program. We all know we start our program with a header file, and the name of that header file is iostream. After that, a namespace will be used to just denote that we are going to use a library which is called standard library. So that's why we can just give a name to all the identifiers that we are going to use in our program. After that, the C++ program will have one main function. Okay, so these are the features of C++. So there will be a main function which is the entry point of the program, but when you will actually use class and object at that time, definitely the main function will not be the entry point. At that time, you'll start developing your program from class. And then here we can see one library function, that is cout. We use this function for displaying any message in the console window. And then there is another thing we can use in C++ is a comment. Okay. In structured programming, if you want to write a single comment, then which symbol you have to use the double slash, right? And for multi-line comments, it will start with a slash start and end with star slash like this. For single line comments, just use double slash for multi-line comment slash star, and then your text that you want to add as a comment, and those comment will not be translated in binary. So after that, you can end it with asterisk and a slash. And for displaying the text, we use a library function cout. Along with that, we use an operator, right? What is the name of that operator? Insertion operator, or we can call it put to operator. Look at the symbol again. After cout, there is an operator symbol, right? So what is the name of this operator? Insertion or put to operator. So it inserts the contents of the variable on its right to the object on its left. Okay, so it will just put the value to the variable that is on the left side of it. And with scene function that we use for taking an input, another operator will be used, which is called extraction operator or get from operator. For example, scene number. Okay, so it extracts or takes the value from the keyboard, because we use this function for taking input from the user from the keyboard, and assign it to the variable on the right side. Okay. And sometimes what might happen that if we want, we can just take multiple uh, input using the same scene function. At that time, you have to use multiple extraction operator. Okay, and what about for cout function? Suppose you can add some additional messages, and those messages will be included within the double quotes. And after that, you have to use the insertion operation. So when you're using multiple insertion or extraction operator in one single scene or cout function, that concept is called cascading. What it is called? It's called cascading. Like here, scene A and then extraction operator P. If I want to take the third input on the same line, just add another extraction operator and write C. And what it is called? It will be called cascading. Is that clear? What is cascading?
Yes, miss.
Okay. After that, what is namespace? Namespace provides the space where we can define or declare identifier, variable, method, or class. And using namespace, you can define the space or context in which identifiers are defined. For example, variable, it's nothing but whenever you have to take any identifier, you have to declare variables, you have to print some message. Every time you have to use the function scene, cout, which belong to that standard library, and you have to write std and double quote. Okay, so if you want to just skip it, then what you have to do? Use using namespace std. After that, there will be a main function, and the main function will have always a return type. Sometimes what might happen that you don't have to write an integer. You can just write main, but by default, the return type will be integer. Okay, so that's why if you define a function using that keyword int, you always have to write return 0. Otherwise, there will be an error message. So in C++, main returns an integer type value to the operating system. Every main function in C++ should end with a return statement. Otherwise, a warning or an error might occur. Because return type for main is explicitly specified as integer, and the default return type is also integer. And then we have, okay, this is a structure of a C++ program. At first, you have to add a header file, and then you can define your class. And then you have to define the members of the class, like the data and functions, and then the main function will come. And this is the end of chapter 2. So let me just show you the structure of a C++ program in simulator. Let me just do that. Is the screen visible to you? Can you see it?
Yes, miss.
Okay. So let's write a program by following that structure we have seen earlier, that at first you'll add header file and then class definition and the definition of member and function and then the main function. So here you can see there is a header file already added, that is include IOStream. And then we can add using namespace std. Otherwise, what will happen? Every time you have to use std double colon with cout same function. And then we can define a class. Suppose we are writing the program for calculating the area of rectangle. Okay. So let's say the name of the class is a rectangle. Okay. And then there'll be a pair of curly bracket and it will end with a semicolon. Now, what is the third thing we have to add in our program? The member of the class. And who are the member of the class? The data and function. So how many data we need for calculating the area of rectangle? How many variables we need to declare? How many variables will be there? I want to calculate the area of rectangle. So how many variables will be needed?
Miss, two variables.
Which two? Length and width. We also need area, right?
Wait.
So let's declare three variables. One is length, width, and the third one is area. Look, I didn't mention the access modifier. That means by default, the access modifier will be private. But the functions need to be defined in the public section. So let's write public and define your function. Suppose the first function is void read, and this function has two integer type parameter like a and b. After that, what you'll do? When you declare the object at that time, we will pass the parameter. So let's say length is equal to a and width is equal to b. That means you are assigning the data to the private data of the class. Okay. So this is our read function. After that, we can define another function called calculation. What it will do? It will just calculate the area of the rectangle. So area is equal to length into width. And how many functions you want to have in your program, it's up to you. And then void display. So it will show the result. So use cout function, and then we can print the message. The result is and then the variable name area. This is it. Okay, so we defined a class and then we declare some properties of the class like the data member of the class. We define some functions. And now in the end, you have to define the main functions. And in main function, we'll declare objects. So rectangle R. So R is the object of class rectangle. Now, the object cannot directly access the data length, width, area. Okay, this will be accessed by the functions. At first, the read function will be called, and read function has two parameters which are integer type. So let's just put some values like 3 and 4. So what is the value of a now? A is equal to 3 and b is equal to 4, and those values will be assigned to length and width. After that, the object can call the function calculation. At that time, the area will be calculated. And when it will call the function display, at that time, the result will be displayed, right? So what should be the output of this program?
And 12.
Very good, 12. So let's see whether we are getting the correct result or not. So here the result is 12. So this is a complete C++ program, and we actually followed the syntax. So there is a header file, IOStream, and there is a class with its member, data, and function, and then there is a main function. Is it clear to you all? Is it clear? In chapter 5, actually, you will write this kind of programs for almost every problem. Another thing I should mention here that what will happen if I don't declare area as a private data member of the class. In this example, area is a global variable, right? But what will happen if I make it local? Suppose I want to declare area in calculation function. So what will happen? In display function, you're also using area, which is not a global variable. It's local variable, belongs to the function calculation. So if I run the code now, it will actually show an error. So what I have to do? Again, I have to declare area in this function. And then what will happen? The program will run. Right. So do I need to just declare the variable again and again? No. So that's why you can just declare the variable in the inside the class, not here. Is that clear? You are not responding. So how will I understand that this program is clear to you? You have to talk, right?
Yes, ma'am. Clear.
So
Yes,
this is end
ma'am.
of chapter 2. Chapter 2 is done. So let's start chapter 3 in the next class. Chapter 3 is about actually uh, data type, and then identifier, control structures like branching statement and loop operators. So let's have the discussion of those
Ma'am,
topics.
can you please repeat what is happening in the main function again?
Okay,
In this
so
code.
in the main function, we are actually creating the objects, right? As we know, the class is the data type and object is a variable of the class. So that's why the syntax of declaring an object is data type, that means the class name, and the object name. Now the object will have values for these data, right? From where they will get the data from the object, but the data are defined in the or declared in the private section. That's why the object cannot directly access the data and cannot assign values in it. You cannot write r dot length is equal to 3, r dot width is equal to 4. You can do it only if you define the function, if you declare the data as private data. So what we're doing here, we are just accessing the data member of the class, that is length and width, through our function. So which function the object is going to call first? At first, read function. And now look at your read function. Read has two parameters, that is integer type. That's why we're passing two integer type data in it. Okay. And then what will happen? Those values will be assigned to the private data member of the class because you have written it here. Or if you don't want to take a value during function call, you just have to use a cin function. You write cin and then you can take the input from, okay, let me also show you that part. And then call the function calculation. At that time, it will calculate the area. And when the object will call the display function, it will just display or print the message. Is that clear?
Yes, ma'am.
Okay, so suppose now here, I don't want to take any data from the program. I want to take the data from the user. So what you can write? Cin length and then width. So now during the function call, you don't have to pass any parameter. So now if I run the program, what will happen? At first, it will ask for the data from me. Okay. It's loading. Uh, Sorry, I just refreshed that page and the program has gone. But you understood, right? What will happen if I use cin function there?
Yes, ma'am.
Just you have to take the input from the user. Okay. And
Ma'am, I have a question.
yes, please. Tell me, what's your question? We can't
Ma'am,
hear
what
you.
kind of question, ma'am, what kind
Yeah.
of question will be asked from this chapter 1 and 2?
So you are not worried about learning programming. You are worried about what kind of questions will come. From chapter 1, some theoretical questions might come, and chapter 2, definitely program, because you are learning the syntax of C++ programming, and this is the base of your programming skill, that how to write programs in C++. And you are asking what kind of questions will come. If you want to be good at programming or in any specific language, don't you have to learn the syntax first, the structure of the program first? So that's what you are doing. In the later chapters, you have to use the same syntax, because I'm not going to discuss about the syntax again and again, right? You'll just write down the program. So that's why I just want these things to be clear to you, that why we're using this header file, why we're using the class, and how we can declare the objects. Okay. So from chapter 2, you have to write programs. Is it clear, Ria?
Okay, ma'am.
Do anyone have any other question? So should I start chapter 3 now?
Yes, ma'am.
Yes. What about the others? Okay, let's
Yes,
do
Yes,
one thing.
Pranab, you should start.
You have your computer with you right now, right? So you should write another program using the same structure. You can write a program for calculating the factor. You already have done that in your lab class, but at that time you just use the simple C++ code, not class and object. Okay. So just rewrite that program again, that for a given number, you have to calculate the factorial, but this time that's all the things will be done in the class. So do it. And in the meanwhile, I can take your attendance.